Bransfield, MD, He's a graduate of Rutgers College and the George Washington University School of Medicine. He completed his psychiatric residency training at Shepherd. He is board certified by the American Board of Psychiatry and Neurology in Psychiatry. Please welcome Dr. Robert C. Bransfield.
I've been dealing with this quite a while. Your average person is someone who is probably an outdoors active person. That's why they're exposed to ticks in the first place. And then they enjoy things, they play, they go outside, hike, or do things they don't have to do. And they're more active than the average person in society in general. And then they end up starting to have these weird symptoms that don't make sense to themselves. So they have this brain fog, they have the tick, they have different kinds of problems that just seem to come from nowhere. And it's like, what's happening to me? I shouldn't be feeling this way. And then their functional levels decline. They have anxiety, they have depression, they have sleep disorders, they have stomach problems, bladder problems, neuropathy, headaches, all these things I've never had before. And they keep saying, this shouldn't be happening to me. I should be feeling better. And then their family says, you shouldn't be feeling this way. And their employer says that, and their friends say that, and their doctor says that, and their insurance company says that, and the medical profession says that. So they feel kind of abandoned and lost, and they feel like something's taking over the body. They don't know what it is, they don't know what to make of it. And then they go around, sometimes from one doctor to the next, and they may be told, well, you have subjective, non-specific symptoms, they're medically unexplained symptoms, so it's probably psychiatric. Bye to a psychiatrist. And it's probably an imaginary thing that you have, you're hypochondriac. And then they kind of get lost in the system, go around in circles somewhat, eventually trying different things. They may do an internet search, and then they may eventually find that Lyme may be behind it, and then they pursue treatment, and then they get into this controversy that surrounds Lyme that they really weren't looking for, but they can't avoid. So that's kind of the typical case that we see. And it used to be, I think my record was, I had one person who had seen 57 doctors before he found someone who had a handle on it. I had someone this week who was 30 doctors, but now it's usually around 5 doctors it takes. So it's not as bad now as it used to be. So what I want to do, there's really two parts of thanks for inviting me, and there's two parts of this presentation. The first part, I'll be talking about the basic tick ecology and tick habitat, that type of thing. Then I'll talk about the psychiatric manifestations. And it's a rather long presentation that I have, so what I'm going to do is break periodically and touch on certain sections and do some question and answer so people don't fall asleep. Okay, so and then the second part, looking at the impact on the brain. So I wasn't really looking for Lyme disease, but it kept finding me. And I've always been puzzled at what caused mental illness, and it does seem infection plays a role there. It's an interesting connection there. And over the years, I've been dealing with Lyme patients a good 25, 30 years, and I see certain patterns. I also run a program for doctors, psychologists, mental health workers who are interested in learning more about tick-borne infectious diseases and mental illness. And now I have 600, we have 600 on this group in around 15, 20 different countries. Now, if you look at an overview, there's really thousands of journal articles that show a connection between infections and mental illness. Three things that particularly come up are more these low-grade relapsing infections rather than acute extreme infections. So it's a more viral, venereal, vector-borne diseases are more your suspects for these chronic infections that have mental symptoms. There's close to 400 journal articles now drawing a connection between tick-borne disease and mental illness. And as clinicians, we see that connection all the time. So what's a vector-borne disease? Now, vector-borne diseases are a specific type of illness where they may reside in animals and then periodically by a vector, a mosquito, a tick, or mite, some other vector, then cross over into another species and then infect people. So you think, let's say, Zika virus, anthrax, plague, malaria are examples. And they do seem to be increasing, or is it increasing awareness? That's unclear. And why is it where people are from different societies or parts of the world are intermingling and then things spread? Climate change may be a part of it. Whenever there's climate change, parasites adapt more rapidly than hosts do. Maybe it's just more awareness. A more crowded world might contribute to it, changes in ecosystems. Biowarfare research, that's a theory that some people hold to, that some people were tampering with things that maybe invented microbes by experiments that then escaped into the general environment. And then warfare environments particularly breed infectious disease, and that's been something significant throughout history. So if we look, there's been a spread of awareness of ticks, and we see it increase from prior years. And if you look at New Jersey really is dead center, and New Jersey's number 2 in Lyme disease, and if number 1 was Pennsylvania, but if you look at the size of Pennsylvania compared to New Jersey, the density of it is quite high. And I think within New Jersey, probably the highest density is maybe Hunterdon County. So we're kind of in the epicenter of it right here. And then we have other ticks. The Oxodes tick is what we think of as spreading Lyme disease, but there's a Lone Star tick. That has a white dot on the back. You do see those. They're a rather aggressive tick, and these different ticks carry different diseases. So again, look at New Jersey, and it pops up Lyme disease, anaplasma, babesia, Ehrlichia, Rocky Mountain spotted fever. There is more Rocky Mountain spotted fever in New Jersey than there is in Rocky Mountains. It's named after the lab where they discovered it. It's not named after the location. So in some ways, it's a misnomer. It really would be better called New Jersey spotted fever instead of Rocky Mountain spotted fever. And tularemia. So when you get a tick bite, you don't just get one disease. And think of it this way: these ticks live in filth. They suck on the blood of wild animals, rodents, rats, mice, raccoons, possum, and whatever they take from that, then they inject in you. And it's who knows what's in that. And every year we discover something new. So Lyme disease, again, if you look at New Jersey, how dense it is, and we're right in the dead center of this epidemic. And some of it, there's a certain ecosystem that's supporting tick populations, and a certain ecosystem that's conducive more to these different infections within the ticks. Now, other way to look at it, it's not just the CDC that keeps statistics, also veterinarians keep statistics. And in some ways, the veterinary statistics are more reliable. Dogs are less political than people. And if you look at Colorado, there's 1,000 cases of Lyme disease in dogs and 1 case in humans. So it doesn't exactly make sense why there's so much more in dogs than in humans there. Is it that the vets are more able to diagnose this than the doctors? And in other places, you look at that ratio. So there's this very good website, dogsandticks.com, and they do a good job of breaking down the different diseases with the state, the county, and you look at that and then you compare it to the human statistics and see how much correlates. And that's often a good question when you're evaluating someone is, does your dog have Lyme disease? And sometimes what occurs is the dog goes out, it goes in the yard, comes in, brings in ticks, they fall off on the sofa, you're sitting on the sofa, and then the ticks get on the person, and then they get infected. Now, another thing to look at is not just dogs, but birds. And you see flyways, and birds transport ticks in sometimes very long distances geographically. So when you live along a flyway, And particularly if you have a big bird feeder in your backyard, and then you have the droppings, and then you have the mice and the squirrel that eat the droppings, that's conducive to it. So flyways are areas where you see more of this, the ticks being transported sometimes thousands of miles from one location to the other. So you can't just look at a regional thing. And also these flyways go along rivers where it's more human. Human environments are more conducive to tick-borne disease. So you think of the East Coast, the Mississippi Valley, the West Coast, the upper Midwest by the Great Lakes, that human environment. And it's also local actually in Hunterdon County, and their houses on an underground spring. And it's a very local human environment. There's a huge amount of ticks there. They keep getting infected. And there's sometimes local environments that are much higher risk than someone who lives a mile away. So if you look at it, there's a lot of deaths from vector-borne disease, particularly more malaria. And it's, again, that environment. But it's Lyme disease, we think of more of a disability than death, although death, I think, is significant when you look at the details, particularly when we look at suicide. So these are statistics from death from vector-borne disease, but they're not taking into account the suicidality. If you look at the United States, then it says there's nobody dies from vector-borne disease in America, which I think is incorrect. This is an interesting map, deaths from MS versus deaths from Lyme disease. And if you look at the map, there's a very close correlation. So a lot of times people say, well, is this Lyme disease? Is this MS? Is this both? Is this Lyme disease triggering MS? Something made somebody's immune system go crazy. What was it? And then now another vector-borne disease, Zika. But Zika, that's in the news. There's a lot more funding for Zika than there is for Lyme, even though Zika probably doesn't get up this far. And probably like anything, if you infect 100 people, some may show extreme symptoms and some mild, low-grade problems, and some people have a natural resistance to it. I think there's some people that get infected by Lyme and do okay with it. They have some resistance to it. And then maybe 20 years later, they have an autoaction or something, and then now their resistance drops, and now they manifest symptoms they didn't show before. So if the polio epidemic, when we had that, people that had a low-grade case of polio who weren't in iron lungs, that seemed to correlate with the development of schizophrenia. So it's, there's, sometimes you see an infection that affects development and altered development, and then that may manifest as disease later on. Other times it's a more current, active, chronic process. So the first is more of a hit-and-run infection, causes some harm to the nervous system. The other is where it's an ongoing process causing ongoing problems. Now, Afghanistan is very interesting. And if you look at it, there's parts of the world where times in history where, think of the Dark Ages in Europe, where there were a lot of infections, and I think those infections correlated with a lot of brain injury, impaired development, which contributed to violent behavior. So I think parts of the world, parts of the Middle East, parts of Africa, where you get this impaired development, this encephalopathy in large numbers of people, that can contribute to violence that's endemic in those regions. I think that happened probably post-World War I, where the conditions of World War I were catastrophic and caused a lot of brain injury, particularly things like Spanish flu, but it wasn't just that. Hitler had Spanish flu and probably was brain injured from that. And then you have the next generation of people that are brain injured from these infections, and that might affect behavior and bring out behavior problems. So sometimes cleaning up violence, you have to clean up the environment and fix that, not just looking at the military option. So these are the culprit here. So there's the deer tick, there's the larva, nymph, and then the adult, the male and female. The best way to tell is look for red. There's that red apron, or the legs can have a reddish quality. If you look at it compared to dime, it's very small, so it's easy to miss. So a lot of times when you get a tick bite, you think, okay, I got it, I removed it, but if you got one, how do you know you didn't have another one that you did not find? right? These are the cycle, and it's about a 2-year cycle where you start out with the eggs, and then you have the larva, the nymph, the adults, and then after 2 years they lay eggs. They have 3 blood meals in their cycle, and in the early phase they go to a host. White-footed mouse particularly, in some ways white-footed mice are more of a culprit probably than deer, because they do more to harbor the development of the cycle, but they're not as visible, so a lot of times we go after the deer. And these animals have a natural resistance to these, to Lyme disease. They don't get sick from it like we do. It's, they somehow can survive with it. We're an accidental host in this cycle. Now, ticks have been around for millions of years. Borrelia has been around for millions of years. They found it in amber in the Dominican Republic. So this is a very sophisticated organism, both ticks and infections, that has great adaptive capability. It's a very formidable opponent here, longer than people, and may still be on this planet after people are gone. So that's a more detailed of the eggs. Every now and then someone sits in an egg nest, and then they get all these ticks that are in tick bites. So there's the larva, the blood meal, the white-footed mouse, and then down through the different hosts. And you can see 1,000 ticks sometimes on the deer. They're particularly around the head and neck region. Okay, so if we really get on top of this and understand it, we really can prevent a lot of disease, disability, human suffering that we would otherwise miss. So it's a great opportunity in caretaker burden. This can disable children early in their life, and rather than being productive members of society, they can have lifetime disability. So we really can make a critical difference by being on top of this problem. Syphilis, there's a lot of references to similarities with syphilis. Syphilis was seen as a great imitator because it would take a lot of different forms. So Lyme is seen as a new great imitator. So it can imitate many things. And it's interesting that if 100 people get infected with Lyme, it may manifest in many different ways. One person may show more as neuropathy, somebody else is GI problems, somebody is joint problems, somebody else is depression or anxiety or sleep disorders. Everybody's a little bit different, although there's a lot of overlaps. The NIH recognizes when Dr. Fallon did his study through NIH and looked at chronic Lyme, he found level of functional disability was comparable to what you would see with congestive heart failure. Pain was comparable to post-surgery pain, and fatigue was comparable to MS fatigue. So that's pretty nasty. That's quite disabling, and it's a significant problem. So it used to be that they would say there's 30,000 cases a year. And then the CDC did a study and said, whoops, I guess it's more like 300,000. And it's probably more than that. So it's the way these statistics are taken. Now, they do we do 3.4 million Lyme tests per year. And that yields 30,000 cases per year of Lyme disease. So that's 1 in 100 that the run-of-the-mill Lyme test picks up. So it's a big debate of how many cases are really out there. And part of it is, what do you call Lyme? How do you categorize it? So it affects more young people, and if you look at the curve there, particularly children that are outside playing in leaves, and then the 40, 45, 50-year-olds, they're susceptible. But you see a drop around the 20, 25-year-old bracket. So those people probably are hanging around bars and nightclubs instead of out in the woods. And I think they're catching other things, but they're not catching Lyme disease. And then when they outgrow that, then they become parents and they become soccer moms and dads and that type of thing, and now they're back exposed to Lyme disease again. So now children are particularly high risk. Another reason, particularly with Lyme. And if you understand it, it's like this. I walk through the woods and there's a deer path, and that's where the deer go. And then there's the underbrush, and that's where the ticks would hang out. And they wait there in ambush. So then as you go through, then they jump on the feet, the legs, and then they work their way up to the top of the body. Now, if you're 6'6", it's a lot longer distance for the tick to get up there. But if you're this tall, if you're a child, it's a lot easier to get up to the head and neck region where they tend to gravitate towards. They often go up the body until there's a constriction. So they may stop where the belt is, or a bra line, or some constriction, but if that doesn't happen, they go up. So, and there was a study that was very interesting, and when the tick bite was in a certain part of the body, you had more symptoms in that part of the body. So a tick bite in the head and neck region, you see more CNS symptoms than if you get the tick bite in the ankle, let's say. You tended to get more symptoms in that quadrant of the body. So, and also children are harder to diagnose. They have they're more difficulty describing it. And another thing about children is it's hard for them to put it into words. And I find it particularly difficult with children because if you're 30 years old and then you get an illness of any sort, you knew what it was like before you were sick and you had a reference point. But if you're very young and you get this, you don't have a reference point of what's healthy. So you don't know, gee, that's wrong to feel that way. And that's a big problem, both in diagnosing it and managing it. Now, there's also quite a bit of evidence with the congenital transmission, a number of articles with that, and there's quite a bit with that. And there I look at sometimes autism, maybe 11%, one study showed, but the more common thing would be an ADHD-like syndrome, that was 56%, and some people, nothing. So it's, particularly if there's a recent infection on the mother, so it's and there are people who say, well, it isn't congenital, but there's enough evidence that's shown that, and there's autopsies, everything. There really is a lot of data. There's one very good article that was done with 888 references, infectious diseases of the infant and newborn, by Tess Gardner. It was very good detail. And then in subsequent editions, they replaced it with another author that didn't do as good a job with it. Who doesn't believe that, the second author doesn't believe that Lyme can cause psychiatric symptoms, which I think is incredible that someone could take that position, but that information is disseminated out there. So you see this, these fetal effects, and now if you look at tick-borne pathogens, it's not just Lyme disease, and there's 300 different strains, but there's all these other tick-borne pathogens. When I use that analogy of getting it's like drawing blood from a rodent and then injecting it in you. That's sort of what, and then what's in there. And every year we have a new pathogen, so it's hard for me to keep updating this list. So, and sometimes you say, well, maybe Lyme disease is just a marker for tick-borne disease. And Lyme disease may not be the culprit, it may be these other things, and who knows what else is there that maybe is more significant than Lyme disease. And that's sometimes the case, because some of these other infections are a lot more lethal or dangerous or disabling than Lyme disease. Now there's debate about how long it takes for it to be transmitted. Dr. Jones had a case, and the child was bit on the eyelid, and within a few hours had a bullseye rash. So you can't say, well, if it's 24, 48 hours, you're safe. I think it depends on a lot of things. There's also transmission sometimes from saliva instead of midgut. So sometimes it's transmitted quickly, and diseases like Ehrlichia and Rocky Mountain spotted fever can be transmitted in a few minutes. So there probably is no safe time. So you can't really say, well, if it was on less than 24 hours, then you don't need antibiotic. But the other issue is, how do you know there wasn't another tick that you didn't find? It could be in the navel, inside the ear, above the hairline that you missed. So when there's a tick bite, I'm more inclined to say, you're probably better off treating it even if it looks like it's been less than so many hours. There's a debate, what's Lyme disease? And it kind of goes back when, a number of years ago in psychiatry, we used to have 3 diagnoses: psychoneurosis, schizophrenia, and organic brain syndrome. And you were one of the 3. But then when you said, well, this is psychoneurosis, what's psychoneurosis? Now, what one person meant by psychoneurosis is very different than what someone else meant. So we see that with Lyme disease. We need to better define what we're talking about. And so there's all these different competing definitions running around. And it's, I could go through all these different definitions, but realize there's that conflict. And basically there's two major schools of thought. One is the school of thought that defines it in a more narrow way, and then another school of thought that defines it in a broader way. Now the people, you know, what definition would you lean towards? I'm more on the broad side versus the narrow side. The narrow people, though, epidemiologists like it narrow and black and white because they have to count numbers, and making it complicated, that's no good, all right? People that want to make money with a product, with a test kit or a drug, you want it black and white so you can do trials and say yes, no, and then you can get FDA approval. And then there's just some people that are black and white thinkers. They just think that way, and it fits with the way they think. So, but in reality, now psychiatrists, we used to be more black and white years ago, but all we had was the Freudian theories. But we found that we couldn't do that anymore. We had to kind of look at a broader perspective. So I think that general psychiatrists, family doctors, people who have a broader perspective are more able to kind of look at a more complex model. But realize that there's those competing models that exist. So here's one way to think of it. There's this restricted definition that pretty much goes with the 1975 definition or so, that it's a bullseye rash, Bell's palsy, and migratory arthralgia. That's Lyme disease. And everybody, and positive on ELISA and Westen Blot. So everybody would agree that's Lyme disease. But then there's, well, what about if it's more a psych presentation? What if there's only 4 bands on the Westen Blot instead of 5? And so then there's that broader definition, but then there's tick-borne disease. Well, maybe it's not Lyme, maybe it's some other tick-borne pathogen. And I think a better concept is complex interactive infection. It's not just one infection, but it's how infections interact with each other. So that's basically the tick talk, and now I'm going to get in more about the mental part of it. Now, maybe I'll break right now. Right. Okay, so now we'll go on more to the mental part. It's not moving. There we go, okay? Okay, so now what I'm going to talk about pathophysiology. So what happens to the brain? Now, here's a basic question. Can infections and immune reactions, cognitive impairments, degenerative neurological diseases, autism, personality, violence, criminal behavior, obesity? That's the question I'll try to address. So this wasn't what I was taught when I was in psychiatric residency, right? So if we look at the history of mental illness, if I would have been giving this lecture a few hundred years ago, what I would say is mental illness means you're possessed by demons. So the solution is that we burn you at the stake, we drive the demons out, and that saves your soul. So then if I were to give this maybe 50, 100 years ago, I'd say, well, it's caused by your mother. When we're not sure, let's blame your mother. You need psychoanalysis that's obsessive, talking about your mother, how she should have and could have, and that's the solution. Now, if I'd have given this talk in, let's say, 1990, when Prozac first came out, I'd say your serotonin is low. Low serotonin is the answer. Go on Prozac, it'll be better. Now, more recently, we look at genes, and we say, well, it's your genes. You have bad genes. Sorry you got bad genes, but that's what you got. Now but none of those are quite right. We have to look at other things. So maybe it's infections, immune reaction to that. So let's put you on antibiotics. But then people say, well, wait a minute, those are subjective, non-specific symptoms. They're medically unexplained symptoms. If you're given antibiotics for that, you're a demon and you should be punished. So we go around in circles here. Now, it's interesting that some of the history of this goes back to New Jersey. And a doctor in a state hospital in New Jersey in 1907 felt there was a connection between infections and mental illness. So he was removing infected organs in the thought that that would help reduce mental illness. So there was some basis to that. Of course, we look at syphilis, that's a prototype, and At one point, half of the patients in psychiatric hospitals were there because of syphilis. So with complicated diseases, we have to think outside the box. We can't think the way we always did, because that won't answer the questions. We have to think like Einstein with time and space dimensions. How does something evolve over time? We have to look at evolutionary theories. Why does disease exist at all? And so there may be some trigger, an infection, an immune reaction, dysfunction, and then disease progression. What evolves over time? This may be looking at days, weeks, years, decades sometimes. So there's things that contribute to disease and things that deter us from disease. And some of those contributors, so invariably it's a genetic vulnerability and environmental trigger. It's a balance between the two. So we have to look at these gene susceptible genes. So two people get the same infection, one manifests disease, the other one doesn't. And then triggering, what are the parasites that may have that triggering effect? And the NIH recognizes this, and this is looking at the microbiome. And if you think of it, 90% of the cells in your body are microbial cells, not human cells, and you're interdependent. So you have an internal ecosystem and external ecosystem. And chronic disease seems to have a lot to do with chronic infectious process, or things within the microbiome. And the microbiome isn't just in your gut, it's throughout your body. Some people think it's just the gut. That's a bigger part of it, but not the only part. And looking at disease model, it's similar transition with Newton and Einstein that we have to make, where Newton looked at a disease of motion and Einstein looked at another level. All diseases, you have a clear trigger, a clear pathological process, and then a clear way that it ends up manifesting. And that solves the easy diseases to figure out, that simple model. We need a more complex model for diseases we're puzzled by now. Lyme, chronic fatigue, fibromyalgia. So the multiple contributors, multiple pathological pathways, and multiple manifestations. So now it's a more complicated formula, but that's what we have to do. So we have more variables, it makes it complicated. So you can't use black and white thinking when you have multiple variables. And Lyme, like I say, has been compared to syphilis, but when you compare it, syphilis is only 22 genes, Lyme is 132. And Lyme can evolve within the body with the plasmids. So Lyme is far more sophisticated, Borrelia is far more sophisticated than syphilis. So it's a lot more difficult thing to treat and get a hold of. It's a more formidable opponent than syphilis. And as I made a reference with the question before, you have evidence that Lyme, Borrelia suppresses and evades the immune system. Now think of it, when we had the Middle East war where it was Iraq, well, the first thing we did, we knocked out the radar. And that's basically what these organisms do. They knock out the surveillance system so they can survive in a host. And they have the ability to do that because they've lived in hosts for millions of years. They have the techniques that allow them to knock out the surveillance. So I could get into all the mechanisms. It's a fairly complicated thing. I don't know that I want to go into all that, but they're out there. It suppresses the immune system in a number of ways, evades it like a number of ways. There's a lot of evidence of persistent infection. There's about 300 articles, and people sometimes debate, well, Lyme should be a lot easier to treat, and it really isn't. And there's a lot of evidence, animal evidence, human evidence, autopsy evidence, et cetera, et cetera. Here's a good way to think of it about disease progression, that early disease, like, okay, I get a tick bite today, I might or might not get the bullseye rash. I think you just get the bullseye rash in the second infection, not the first. And then you get the early symptoms, and then you get later symptoms. Now, in looking at the CNS symptoms, you get a mild cognitive impairment at first, and then it increases with time. And this may be over decades. And then the emotional symptoms can be just irritability, low frustration tolerance, but then that can evolve more to sleep disorder, anxiety, depression, more extreme things, temporal outbursts. And then you get the vegetative symptoms at the brainstem, and that can be the sleep disorders, sexual disorders, eating disorders, and then increases with time as you get disease progression. Now, another way to think of it is, let's say a flu goes around and somebody sneezes on you. Okay, what happens is I get that bug, and now I get inflammation. That's my early response to infection. Then my body figures out what it is, makes antibodies, I have adaptive immunity, and now I'm fine, it's gone. Now, that's what we want to have happen, but somehow with Lyme, you never get adaptive immunity. You can get Lyme 100 times, and that's why when they gave the vaccine, they had to keep giving boosters, and still people weren't fully protected. So you, instead of getting adaptive immunity, and you're fine and it's gone, you get persistent infection, you get persistent inflammation, and you might get autoimmunity. So you never quite beat it, and it keeps causing symptoms. Now, one thing that I think people get hung up on is a lot of people that are considered thought leaders in Lyme disease know absolutely nothing about psychiatry. I see that with the CDC. There are no psychiatrists in the CDC. And then they come and they try to explain something, and they say, well, this is mass hysteria. And they're epidemiologists who know absolutely nothing. They don't know how to make a psychiatric diagnosis. Psychiatric illness doesn't fall out of the sky. It's always caused by something. Think of it like this. We have adaptive mechanisms in our body, like fear, and a lot of these things are good, and they are like gear shifts in a car, and they allow us to adapt to different life situations, whether they're cognitive, emotional, or vegetative. And when they work for us, we're afraid of things we should be afraid of. But when we get impaired, then these adaptive mechanisms are too much of one thing or another. So there's too much aggression or too much apathy. There's one extreme or the other, or both. It's not regulated properly. So when we get it dysregulated, like our gear shift is off, that's mental illness. Something impaired that circuit, something damaged that circuit. So rather than adapting the things the way we should, we get stuck. And a lot of times we see, let's say, hyperarousal, where if I get upset by something, now I'm in that hyperarousal state and say, okay, it's over, calm down, relax. People can do that, but a lot of times you see where that gets turned on, you can't turn it off. People can't shut it off. That's an impairment caused by something. So what are the usual suspects for mental illness? And it's not just Lyme disease, but there's this big long list of spirochetes, bacteria, viruses, protozoa, parasites, fungus, and it keeps growing over time. So there's a lot of data with this that really do have a lot to do with mental conditions. So it goes beyond the old Freud. It makes sense, and when you can explain the details, it really makes a lot of sense. So if you look at, let's say, different psychiatric illnesses, like if we both get infected, or a bunch of us do, maybe some of us get no manifestation, somebody else gets psychiatric, somebody gets physical, and one person may get depression, somebody else gets panic attacks. So it could be different manifestations in different people. A lot of times it's not the infection that causes a symptom, it's the immune reaction to it. So it's like friendly fire in a war, where we shoot our own troops by mistake. So it's the infection's there, it provokes the immune system, and the immune system reacts, and it's that immune reactivity that causes the symptom. When you get an infection and you get fever and chills, that's your immune system, that's not the infection. It's the immune system reacting to the infection. This is an example of a white cell. And white cells are supposed to gobble up bacteria and destroy them, but in this case they try to gobble up spirochete, and instead the spirochete destroys the white cell. So it's like, that's not supposed to happen, but it does. Same thing can happen in neurons. This is autopsy of someone who had Lyme disease and he had mental deterioration. Some of these people get this rapid dementia that they nosedive, and if they stay on IVs forever, it slows it down, but it's inside the central nervous system. Now that's a small percent of people. Most of the people don't have this, but you can see it inside neurons. Now, looking at that link, you have an infection in the body, provokes the immune system, that causes symptoms. So there's 5 articles now where we look at that, and we look at that link. I'm not going to go into all that, but there's articles that do. And when you have that infection, it impacts the immune system. And different infections have like a fingerprint of how it provokes different immune transmitters. We call them cytokines or chemokines. And sometimes by looking at that immune profile, you can pretty much guess what the infection is. Now, when we look at it and we look at, let's say, different psychiatric states, we find with a lot of different psychiatric illnesses, we see immune things that are high, immune markers, particularly interleukin-6, which goes with inflammation. Whether it's sleep deprivation or schizophrenia or autism, but interleukin-6 is high with all of them, but you see other ones, particularly CPK. Now, then another thing that's autoimmune reactions. And if you remember, I said normally you get infection and then you get adaptive immunity and you're fine, but instead you get persistent inflammation with this and sometimes autoimmunity. PANDAS is a good model of autoimmunity where someone gets an infection, and strep was used as the original prototype, but it goes beyond that. We see it with Coxsackie, you see it with tick-borne diseases and other things. And then when you start to make the antibodies, you can make antibodies against brain tissue, against neural tissue. And then all of a sudden, boom, you see these tics or OCD or irritability or bladder symptoms that weren't there before. It's a sudden onset, correlates with that lag period when you make the antibodies. And some people have more of this component, this autoimmune component, than other people. So there's a lot of crosstalk between the brain and the immune system. The brain and the nervous system and immune system are very similar. They both have cell-to-cell communication. They have innate adaptive reactivity, and then they have learning. And disease can be errors of learning. But even though there's a lot of crosstalk between the brain and the immune system, there's not a lot of crosstalk between psychiatrists and immunologists. We need to do more of that. But the crosstalk does occur in the field of psychoimmunology, which is the study of the immune system. And there's a group of us that look at that. And we meet in Germany every 2 years in a castle. It's kind of neat. And there aren't a lot of people that get that and understand it, but I think that's the future of psychiatry, is psychoimmunology. That explains a lot of the causes of mental illness. Here's an example of how it works. Now, you have infection in the body, then causes immune activity in the body with these cytokines I was talking about. Those can then cross the blood-brain barrier and cause an immune reaction in the brain. So you do not need infection in the brain to have brain symptoms as a result of infection in the body. That's a big distinction. A lot of people think that, well, let's look to see if there's infection in your spinal fluid, and if there's white cells in your spinal fluid or signs of infection in your brain, then only then can we say it makes sense. But most of the cases, and we call it encephalopathy, different than what I was talking about before with some of these rapid dementia cases, where there are infection in the brain itself. The vast majority of this is infection in the body, provoking the immune system, and that immune provocation causes mental symptoms. And that can explain why it fluctuates, where it can come and go, where the cytokines can peak, and then you see more of that brain fog that comes and goes, and it makes sense that way. So infection in the body can provoke symptoms in the brain. I had one patient, he ran a good part of the government in the morning, and he was okay, but then when he came home, he couldn't find his house. He was a couple blocks away from his house. But at that point, he had the brain fog, he had the cytokine activity increase, so that's that fluctuating ability. Whereas if it were infection in the brain, you would just see that constant low level of impairment. It wouldn't fluctuate to that degree. So when we look at mental illnesses, when we look at depression, schizophrenia, we see markers, immune markers, that are very high. So it makes sense that why is it that whenever we look at mental illness, we see something going on with the immune system? That's that connection. This is an interesting study that was just done recently. And when they looked at depression, And when someone's depressed, different genes are turned on and turned off. And in a study, they showed 90 genes are upregulated with depression and 70 genes are downregulated. And when they looked at it more carefully, 75 genes are downregulated. The genes that were upregulated and downregulated were immune system genes. The ones that were upregulated were inflammatory, that early marker of infection, and the ones that were downregulated were the adaptive immunity genes. So it shows that if you look at that, well then depression is an immune disorder. Therefore infection is probably the #1 thing that provokes the immune system. Not the only thing, but usually the first thing you think of is provoking, you think allergies, you think of other things, or cancer, but so it's quite different from what we were told, what we thought. So going back when I was in medical school, if someone would say, well, someday you'll be looking at ticks to explain obsessive compulsive disorder, it would have been hard for me to wrap my head around that, but that's the reality. We have to be adaptive and adjust to the information that's there. As science evolves, and as information evolves, we have to adapt to it. We can't be attached to our old belief systems when we find evidence to the contrary. That's the nature of science, that when you get information, you have to shift and adapt to it. So this is another interesting study that just came out. What they found, now here we're not looking at infections in ticks, we're looking at tick saliva. And tick saliva affects dopamine. And so therefore, now dopamine is your reward pathway. So when you do something good and you feel good, you get a lift. This injures that. So, and this is tick, not the infections in tick. The tick saliva itself causes an immune reaction that harms your dopamine responsiveness. So now it's hard to feel good. It's hard to feel good from good as a result of this. Does this contribute to the opioid epidemic where people then can't feel good? And then they turn towards something to try to get a lift. So you don't want to be the control group in a tick infection because where the tick has no microbes, because you'd still be harmed from the tick itself, not just from what the tick is carrying. All right, now this is a study that was done in 1990. And if you look at it, so this tick was 74%, depression 37%, irritability 26%. Another similar study done by Dr. Shea, who's going to be talking later, he had the same numbers. He had the same numbers with tick, depression, and irritability. So it's very consistent. It's the same pattern. I'll talk about the patterns again. Now, if we look at other autoimmune diseases like arthritis, lupus, we can see problems, but by far and large, you see far more problems, far more mental symptoms with Lyme disease. So Lyme disease is worse in provoking the immune system than other recognized immune disorders. So let's look at the symptoms that people have, okay? I don't know if anybody can relate to some of those pictures there. So there's sickness syndrome. And sickness syndrome is you get the flu and you just feel, you feel drained, you feel malaise, and it's blah, and basically your body's fighting a battle inside, compared to stress syndrome where you rally to fight out your allocation of resources inside. Withdrawal, so basically that's depression. So when you get immune inflammatory reaction, it pushes you towards basically depression. That goes with that other slide that I showed about inflammation with depression. Now, chronic stress, now you get something that gives you sickness syndrome, but you're also trying to go about your life and do all your responsibilities, so now you're stressed by that. So now you're fighting a battle on two fronts at once and you can't do it well. So that doesn't help, it can contribute to increasing disease progression, right? So what starts a disease isn't always what causes it to progress. So you can get started with that infection and then you get stressed, sleep deprived, and it's a vicious cycle that keeps going. Now, think of sleep, and that's a critical thing, and I think this has a lot to do with breaking the cycle of chronic illness. Normally in a healthy state, like you jumped out of bed this morning at 6 o'clock, you can't wait to attack the world, you have lots of energy, you get a slump in the afternoon. If you're British, you have tea and crumpets or so. If you're In Spain, you have a siesta. If you're American, you just ignore it and drink more coffee. And then you get deep sleep in the beginning of the night, REM sleep towards the wee hours of the morning, and now you're ready to attack the world again. But when you have these chronic illness, you kind of drag out of bed, you're half awake, half asleep 24/7. You're not awake when you're awake, you're not asleep when you're asleep. You don't get restorative sleep, your circadian rhythm is off. Key thing, I think, with chronic illness. If we do a sleep study, the first part of the night you should have that stage 3, 4 sleep, cycles of it. That isn't there, it's like the lower line. And then when you get the non-restorative sleep, invariably that goes with terrible triad. Non-restorative sleep, fatigue and cognitive impairments. But it also goes with emotional reactivity, lability, pain sensitivity, and immune dysfunction. That's a big part. This is a key thing in perpetuating these problems. And if you think of it, okay, so if you have a in two ways. One is with antibiotics, but another is by helping your own immune system to be more effective. And in many ways, that's a better approach. Because your immune system is smarter than I am in being able to figure out what to go after. So it's a very complicated formula we haven't really touched on. So let's look at assessment. So this is sort of what I was talking about in the very beginning, where I'm looking at what's acute Lyme disease, first of all. So you classify things of all the rats. Not everybody gets that. It isn't always a bullseye. You don't always see it. And then, so that's one thing to look for. But then, is it something else? Action, ringworm, a lot of people think spider bites, that's part of the differential. A good way to screen is, do you live in an area where you're exposed to ticks? Do your neighbors have it? Do you do activities where you're exposed? Do you have a dog? Is your dog infected? Is there a history of tick bite? Is there a point in your life where you were healthy and all of a sudden you have all these symptoms that just came in a domino effect? Have the antibiotics ever caused an improvement followed by a worsening, which is a Herxheimer reaction? So these are giveaways. Now, when we assess it, it's certainly harder in children because they're not good at saying what normal is or describing how they feel. We do an in-depth assessment, like I made reference to before, and is there that point, that demarcation where you're healthy, and then all the in a progressive decline where over time you get more and more symptoms that increase over time. And it's pattern recognition. You can't use any one test right now that's good enough to rule out Lyme. I wish we had the test, but we don't. Be realistic. So this is the assessment I do, but I'll expand on it. So you look at cognitive functioning, psychiatric symptoms, vegetative meaning sleep, eating, sex, temperature control, neurological, musculoskeletal, autonomic nervous system, genitourinary symptoms, cardiac, GI. So it affects the entire body. Not many things are multisystemic. And a point two here is you can't, if you get multisystemic illness, that's not psychosomatic. Psychosomatic are never multisystemic. If you're psychosomatic, you maybe are prone to irritable bowel or headaches or shaking or tremors, or it doesn't affect the whole body like this. You're prone to whatever you're prone to when it's psychosomatic. So to break it down, the average case, you look at cognitive functions, attention, memory, processing, imagery, executive function. That's the cognitive. Attention, you see what looks like an acquired attention deficit disorder. True ADD you're born with. It's in the womb. You don't acquire it at some point in your life. And it's an ADD-like, but not exactly. People tend to be more hypersensitive to sound, touch, sensory input. They get flooded by sensory input and feel overloaded. There's memory problems, and also sometimes there's a selective thing like I get annoyed by mouth sounds, or there's this hyperacusis to sensory input that wasn't there before. And a lot of sunglasses and hats with brims, and I can't handle the light in the box store, it annoys me. So then memory problems, particularly working memory, short-term memory first. Long-term memory is better preserved, particularly if it's long-term memory that predates the onset of the illness. And then there's a slowness of retrieving words. It can look like dyslexia-like, where there's errors in sequences. And then processing. What you often find is slow processing. used to work in a mental health clinic in North Carolina. And when I went there, they said, you know, it's the weirdest thing, we can't figure it out. You'll be in a small consultation room that's the size of a bathroom. You'll look at somebody in their face and then say, how are you doing? And they'll sit there for a couple of seconds with kind of a blank expression and then say, who? Me? And it's like, well, who else am I talking to? And I found one person after another was doing that. I was trying to, why would someone do that? And I think looking back, these were loggers, and a lot of them had Lyme disease. And this was before we paid attention to Lyme disease. And they were buying time because they had slow processing. So they were in the habit of saying, who, me, so they could collect their thoughts before they could answer. So you see this slow processing. And there's two ways to think of it. One is receptive and another is expressive. Receptive slow processing is a little bit like a Peanuts cartoon, where when the adults are talking, it's wah, 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 wah. So it's like people are talking and I hear the words, but I'm not digesting the content, boom, 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 as the person's doing it. If I'm reading it, I can do it slow and I can keep with the pace. But I can't keep with the pace fast enough to understand the content. With expressive, you can see it where someone's groping to find the words that they're trying to say when they're talking, or they make errors. So that's a processing impairment. It's a white matter dysfunction. And it goes with the findings that we see with white matter encephalopathy. You see imagery issues. A lot of Lyme patients, and it's a temporal lobe finding, have these intrusive horrific images. They can be thoughts, feelings, emotions. It's almost like being on these cheap horror movies. It's like, where did that come from? That's not me. And it's, one patient described it invades the privacy of my mind. Impairments in directed behavior. So you see brain fog, time management problems, absolutely atrocious with time management. People that used to have good time management, multitasking, organizing, prioritizing, a lot of that goes out the window. And then emotional symptoms, first thing, low frustration tolerance, irritability, hypervigilance. Then you can see more extreme things, sometimes dissociative episodes, depersonalization, anxiety, depression. You see disinhibition, road rage, people lose their temper more easily, a lot of marital conflict, a lot of interpersonal conflict, a lot of lower level functioning with work and school. There was one person on Wall Street that managed a big fund, and then they came down with Lyme disease and they lost $2 billion because they lost their edge. So then the psychiatric syndromes, depression's very high. Sometimes you see bipolar. I think Dr. Greenberg will talk more about that. Panic attacks. And the difference with these panic attacks, they go on and on. Other panic attacks are very brief. It seems like an eternity. It's only a couple minutes. Whenever a panic attack is more than a half hour, it's from Lyme disease. I found that to be very consistent. So, and then OCD or different kinds of obsessiveness, social anxiety that wasn't there before, generalized anxiety that wasn't there, it's any psychiatric syndrome. Sleep impairments is pretty much 100%. And non-restorative sleep, and then eating a lot of times, temperature control, sexual, sometimes hypersexuality, more commonly hyposexuality, particularly sleep disorders, the eating disorders, carbohydrate fluctuations, sexual, the temperature control that I was talking about before, sometimes night sweats and chills. That particularly goes more with the Babesia and Bartonella. Neurological problems, a lot of headaches. There are about 8 different kinds of headaches. The most common in the back that radiates up here, but sinus, thunderclap, where you're just zapped. There's a number of them. Cranial nerve problems. Invariably you find cranial nerve problems, not just the Bell's palsy. Seizures, partial seizures in a fair number of people. Neuropathy, numbness, tingling, crawling. Then motor problems, weakness. So those are the different kinds of headaches, the cranial nerve problems. So a lot of eye problems, quite a broad span of eye problems when you do a thorough exam. Then those are the different ringing of the ear, altered smell, taste, trouble with swallowing. Then other neurological problems. So I do neuro exam, looking at these, and then you look at the body as a whole, musculoskeletal problems, the joints, the muscles, bone tenderness, GI, genitourinary, that's musculoskeletal. Cracking of joints, you can't sneak up on somebody anymore because your joints crack. Then air hunger, sometimes POTS, you see microprolapse, but again, all these are things that can be independent, but it's a cluster. You see that clustering effect. GI, a lot of times reduced GI motility, so that you see sometimes cyclic vomiting or slower GI motility. Things don't move the way they used to. So it's, we also see irritable bladder that you didn't see before. Autonomic nervous system problems. Now, look for Bartonella. That's a rash. And if you look at that, it's a little different than Stria because it's more red at one end than the other, almost like a boat wake. And they can be there when you think of those with weight, where someone has weight or pregnancy or skin expansion, but these can be under the arms and the legs with someone who isn't overweight. That causes Bartonella, also tenderness in the bottom of the feet. The immune testing has very serious limitations. This is what the CDC says, although the bottom part, that's the surveillance criteria. And the surveillance recognize that there's a difference that people confuse surveillance criteria, 30,000 cases a year, with diagnostic criteria where there's over 300,000. Confusion about how to interpret these tests that I'm not going to go into so much here. The reliability of the two-tier testing is based on studies put together. Let me just, I don't want to belabor this. This was the Dearborn meeting where they said, well, let's eliminate the band 31 and 34 because we want to make money on those bands with vaccines. But those are the tests that are particularly critical when you're looking at autism. Now, if you look at two-tier testing, it's used with AIDS, but the reliability of two-tier testing with AIDS is 500 times more reliable than two-tier testing with Lyme disease. So there's a big difference there. There's also debate. To get a test approved, people get confused about CLIA versus FDA approval. FDA approval means it's as good as tests that are out there. But that doesn't mean that the tests that are out there were ever standardized in the first place, which they never were with Lyme disease. CLIA is the organization that really standardizes tests. So a lot of times people argue, well, that's not FDA approved. Most of your university tests are not FDA approved. That's only for mass marketing or mass production. It has nothing to do with saying it's an accurate test. CLIA says that it's accurate. So what makes sense? Looking at the total clinical picture or looking at, some of these FDA or CDC criteria, a lot of these people are bench scientists, they're epidemiologists, and they don't know much about medicine. So you have to look at the broad picture, you have to bring everything together. I think the newer test is this immune testing, this DNA testing. I'll show a picture of it. And this is what it looks like. So you have these dots, and those are DNA markers. This is the future of medicine. And you can do this and go through, let's say, 500 different pathogens or 500 different immune markers. And then you can say, what pattern of pathogens go with this? What pattern of immune markers? This is in research, and I think in 10 years or at some point, this is how we will make the diagnosis. This is the future of medicine, is looking at this type of technology, this DNA-based assessment. We do imaging studies that help some, but it's not black and white predictive. Here's a good example of before and after. On the left side, show dark means less brain activity. Yellow and orange means greater brain activity. So this person has a lot greater activity after they had like 16 months of IV antibiotics to get better. MRI testing, you can see what's called hyperintensities. And a lot of times this is confused with MS. MS and Lyme on an MRI look pretty much the same. And the difference is, on Lyme, these findings on its MRI come and go. they disappear, whereas on MS they're more likely to stay. So no single test is a gold standard. We love to have a gold standard, but it doesn't exist. You have to look at everything and have to add it all together. Differential diagnosis, chronic fatigue, fibro. Chronic fatigue is more abrupt onset. You know, where at 3 o'clock in the afternoon on May 31st, I just crashed and I never felt right since. You have chronic fatigue with Lyme, but chronic fatigue syndrome is different. Fibro, you can have fibro with Lyme, but you can have fibro with other things. Epstein-Barr, I think Epstein-Barr can be a trigger. I see a lot of people that probably have no infection Lyme, then they get Epstein-Barr, mono, and then boom, they took a nosedive, and then they don't come back. There's somehow an interaction there. Lupus comes up a lot, MS, hypochondriasis. So if it's multisystemic, it's invariably not psychosomatic. A lot of people confuse that. And if you have a psychosomatic illness, you've had it your whole life. It doesn't begin in midlife. Example is, let's say irritable bowel, you've had it your first day of kindergarten, you've had it all through life, stress, it flares up. That makes more sense. But if all of a sudden you get a heart problem, a bowel problem, headaches in midlife you never had before, never psychosomatic, never. Okay, but you can, somatopsychic is another thing, where you have all these medical problems and then you have emotional distress from it. That's different, right? So common error is Lyme disease does not cause mental symptoms. The symptoms are subjective. Now, when they say subjective, it's really anything that's subjective. What's the difference? So if I say, I have numbness in my hand, that's a subjective complaint. We could do nerve testing, we could do biopsy and show neuropathy, and that makes it objective, all right? But you always have to do that when you know that you can measure it. If someone has that cognitive impairment, that slow processing, we can have Dr. Shea do psychological testing, and that makes it objective. So do we have to do all this battery? Sometimes, we particularly want to do it with legal cases we're arguing, but a lot of these things that some people call subjective are a result of inadequate exam, or what they call medically unexplained symptoms. Medically unexplained symptoms are often inadequately examined symptoms, inadequately assessed symptoms by someone who doesn't know what they're doing in that part of medicine, all right? So saying they're non-specific, most symptoms are non-specific, it's pattern, like chest pain. Chest pain doesn't mean heart attack, but you have to look at pattern recognition. Headaches, fatigue, what's the pattern? Patterns are specific, even if individual symptoms aren't. So this is like a word game almost. And then the thinking that psychiatric symptoms just fall out of the sky, they don't have a physical basis. And one time I was looking at a deposition, and it was one of these so-called thought leaders in Lyme disease, and they said, well, what's your background in psychiatry? You're making all these claims, what do you know about psychiatry? What was your training? I said, well, I had a rotation in the state hospital 40 years ago when I was in medical school. And that's what they know, and it's amazing how little some doctors who are super specialists know about psychiatry. And I think, so super specialists I'm always wary of if they don't have a broad knowledge. Family doctors are people with a broader interest and motivation where they can pull things together, they can better see the psych part and make sense out of it. So, and then they're thinking, what's more reliable, the lab test or the clinical assessment and your judgment? Are patients liars? Do people suddenly lie about all these things whereas they never did before? That doesn't exactly make sense. So we have to differentiate what started it from what caused it. And then when I do an assessment, I say, okay, what's your worst symptom that keeps you stuck the most? What's second, third? And then we attack that in that order. That's a good approach. What symptoms impede? And often it's the sleep disorder, fatigue, cognitive, the emotional problems, stress, chronic pain. Those are common. So the consequences, we can see autism in some cases. We can see different infections that clearly show a link with autism. There's a number of them. Then when we look at it, I've done a couple articles on this. A lot of tick-borne infections, you can see a correlation with autism. You can also see that there's that reactivity of 31-34 band that correlates more with severity of autistic presentation. Particularly you see it with regressive autism, where someone's healthy and then at the age of 2 they do a nosedive or so, and they suddenly become autistic, whereas they weren't before. So these are some of the articles that I've done, or other people have done with autism. Schizophrenia comes up. Now, if you look geographically, schizophrenia doesn't have an equal geographical distribution. The red shows states where it's more prevalent. But you also look at the bottom and it shows the states where these tick-borne infections are most prevalent. Interesting correlation, somewhat like what we showed with MS. Intrusive symptoms, I made a reference to that before. That's something I pay a lot of attention to, is you get these intrusive, horrific things that just come. It goes with temporal lobe dysfunction. And a lot of people that had this, when they get treated, it improves, but it really is torture. And people are reluctant to talk about it, where they, their atrocious thoughts, they come of doing harm, sometimes killing or blood and gore. They come from nowhere. It's like, that's not me. Why am I thinking that? Oh my God, that's a terrible thing to think. But they have it, and it's part of the illness, and when you treat it, then it improves. Did a study on that where I looked at 131 patients and was able to see patterns of who had the intrusiveness, and it correlates with inflammation. So inflammation, particularly affecting the temporal lobe, contributes to that. Then other things, Lyme and suicide. So that's what we're really talking about. 20 years ago, I did a newsletter article on Lyme and suicide, and that was kind of the main source of information on this subject for a long time. So Dr. Shea asked me to do a talk on Lyme and suicide at the ILADS meeting. So then it kind of forced me to, well, I better do it in a more methodical way. And then I researched it and realized, wow, I have to really do more with this. And then I ended up putting it in a journal article. And this is really a big issue here. This is a major problem. So part is you're frustrated at how all these things are happening, but there's a physiological thing that makes people suicidal. Let me just ask a question. How many of you know someone with Lyme who's committed suicide? Raise your hand. Okay. It happens more than you realize, and I think a lot of cases go under the radar, and I think a lot of suicides is a Lyme basis that was never picked up. So we see a causal relationship. Now, there are studies looking at the fact that infection correlates with suicide, not just Lyme, any infection. Immune provocation, like the hepatitis C treatment, goes with suicidality. Outdoor workers go more with suicide. Farmers, loggers, forestry people have more suicide. So people that are in that outdoor environment have it. So it correlates with that, and these were people that were not suicidal. You can explain the physiology, it makes perfect sense when you look at the biochemistry. And it seems that the people who are more suicidal have this whole cluster of psychiatric symptoms that increase suicide risk. They might have the depression, the dissociative episodes, the depersonalization, the panic attacks, explosive anger, the intrusive symptoms, hallucinations, substance use, on and on and on, and all these things added together can increase suicidal risk. This was the study that I did where I looked at 253 charts, and a very high percent were suicidal, and a significant percent of the people that were suicidal were also homicidal. So now what I'm looking at is the homicidal group. I'm looking at 50 people that were homicidal and 50 Lyme patients who weren't, and it's like, what's the difference? And actually, if you look at that, it's a very small percent of Lyme people get that degree of aggressiveness. But that, you don't want any of it. And you don't want to stigmatize the people that don't have that, but there are differences, and it's good to understand that. And understanding that may help to prevent violence. A lot of these infections can contribute to violence in certain parts of the world, and if you fix that, you can fix a lot of the violence. So this was the different groups. These were the people that were looking at the first column as the people that were suicidal and homicidal, but people that were neither suicidal or homicidal. So generally they had less of this mix of explosive anger, intrusive symptoms, sudden mood swings, paranoia, dissociative episodes, hallucinations. The more you see these really kind of nasty symptoms, the more the risk of suicide, panic attacks, and GU symptoms, all right? And so there were other things that didn't correlate so much, that just are part of Lyme, but didn't necessarily correlate with suicidal risk. So when I looked at the numbers, this was the physiology. So a person gets the infection, then they get this inflammatory response, and you see that with the hepatitis C patients, where they also get suicidal. There's a way it affects quinolinic acid and NMDA receptor. This is all in my article where I explain in more detail. And then that makes someone suicidal. There's a physiological basis to it. So it's not just feeling, I'm frustrated that nobody's helping me. That adds to it, but there's a physiology, a biochemistry that makes someone suicidal and sometimes homicidal. So when I figured out and added up, I think that really there's a very strong connection, and if we pay more attention to this, we could prevent a lot of suicides. So then, how many suicides are we talking about? And when I did the math, I figured it's probably 1,200 a year in America, probably a couple hundred in New Jersey, and those are suicides we can prevent. The people that I looked in this group, the average person went 8 years before they were diagnosed. So if you diagnose their a lot of them really were very healthy before they got sick. They didn't really have pre-existing problems. They acquired it after they had the Lyme disease. A lot of them had a lot of co-infections. Those were the worst cases. They had more co-infections. Now violence, it's a little different pattern. But violence, you see this additive effect of all these psychiatric mixed symptoms, and each thing makes sense. You can think of violence a couple ways. One is impulse control disorder, 2 is psychotic, and 3 is predatorial. So impulse control disorder is like road rage. I lost it. I lost my temper. I don't have the temper control I used to have. Psychotic is somebody's out to get me and I have to protect myself. It's paranoid, delusional. But predatorial is different. Predatorial, it's a lot harder to understand, but invariably you sometimes see that with herpes infections and what we call Kluver-Bucy syndrome, where there's a damage, and now the interpersonal, the bonding, the empathy doesn't work anymore. So an example would be if somebody says, what prevents you from doing a harmful thing? If somebody says, I'll give you $1,000 to do something harmful to another person, we do it. No, it just doesn't feel right. And a person can, but that doesn't operate with everyone and some people that are brain damaged, that's not there. So they don't have that normal empathy, that interpersonal emotional connectedness. People aren't seen in that human way. It's almost like a acquired type of narcissism, like a predatory behavior that was not there before the infection. Invariably, when I look at those cases, these were people infected very young. They get the predatorial kind of thing. And it's a very small number, but these are the most dangerous that have this pattern. The most common are the explosive rage, where they just lose it and they can't contain it. But we can prevent violence by understanding these things, treating them early, and preventing it. That's the good part, right? You also see some dementia, but I think there's 2 patterns. There's one pattern where it's actually infection in the brain and a rapid downhill course. These people just crash. But the other is more of a low-grade thing where it's in the body, and it's a very slow thing over very many decades. Failure of restorative sleep often goes with progression of dementia. Now, this is, we have these different guidelines. I'm going to go through this kind of fast. There's the ILINES and IDSA. We debated, that goes more with the narrow versus the broad definition. The IDSA guidelines more so goes with that more restrictive definition, putting more credibility in the lab testing. ILADS goes more with a total clinical picture. We pay attention to lab testing, we pay attention to clinical symptoms, we pay attention to clinical judgment and pattern recognition. It's a more complicated criteria. Evidence-based practice we pay attention to also. And the proper definition, a lot of people misuse the definition, is the blend of the best research evidence. You never have absolute evidence. Clinical expertise and patient preference. That's evidence-based medicine. You can often see different groups. You see people that have this restrictive view of Lyme disease, and then you see people that kind of jump on it and do all kinds of weird things. But then you see the people that have the classic medical approach where you just do a thorough exam and you do old-fashioned medicine, and that's what I think is the best, and that's what we recommend people do. But then you have this other people that are just watching this whole debate, and it's like, I don't know what to make of it. And now there's some people that are like the silent majority, there's the phrase, and there's some people that just follow somebody's guideline, just black and white, and sometimes they pick the wrong guideline. And so there's this debate rages. There's always debates in medicine. And whenever there's a debate, a lot of times we get involved in psychiatry. And then once the debate's over, then the psychiatrists move off, and now we get involved in some other debate. So there's that restrictive definition of discounting anything that doesn't fit with their belief system as being subjective, non-specific, medically unexplained symptom, or now a phrase, post-treatment Lyme. Was it effective treatment? Was it partial treatment? What do you mean by post-treatment? That doesn't make sense, right? And let me see. So this is a joke I did. You know, your average person who comes in for treatment, and then they say, well, the lab test is negative, and even though you're in a wheelchair, you don't have Lyme disease. And then just because we've always done it that way doesn't mean it isn't incredibly stupid. And then we have issues from the healthcare system where you have healthcare middlemen, and that's what's inflated healthcare costs, is middlemen, not doctors being paid more. And they come in the middle between the patients and the doctors, and I think that's a big issue now in medicine. And then we get on the phone, we talk to misdiagnosis and try to get approval for treatment, and that's an issue. And so then, you know, is this whole thing going to break loose? I think it would be, because how long can you say this is nothing, this epidemic? So there's this great burden, and we can do something that can help fix it. So pattern recognition is key. So basically, when we look at all these things, we get further. Lyme disease, you have to look at ecology, medicine, neurology, psychiatry, immunology, law, politics, ethics. You have to pull it all together, right? So we want to do something about it. So any questions? We're kind of running tight on time. So
We got 5 minutes for questions.
okay, right ahead.
Are you